My name is Niki Parenteau, and I'm a research scientist at NASA Ames Research Center. I'm interested in looking at very primitive photosynthetic microbes and trying to characterize what we call biosignatures that they produce so that that can guide us when we go out and look for evidence of life within and potentially beyond our solar system. So, the search for life on exoplanets. I study microbes that grow in extreme environments like hot springs, really salty ponds. I also study what they look like along the shoreline, along the ocean. There are microbes that grow there. And I try to characterize their biosignatures. And what I mean by that is a signature that they produce that's indicative of life that cannot be produced abiotically, meaning in the absence of life. So for instance, even when we just look at, a rock, compared to the algae, we know that this is life and this isn't, but how can we distinguish this on an exoplanet? If we think about the potential for these microbes to grow on the surface of an exoplanet, we need to think about how that might look like to a remote observer, to a telescope. So if you think about a star being right here, and the light from the star coming in and bouncing off of these microbes and then going to your telescope right here, I characterize this spectral signature. It's called a reflectance spectrum. However, we also have to ask the question, what would just a rock look like on an exoplanet? So you have to be able to distinguish life from non-life. So I also measure how light comes in and bounces off a rock and goes to a telescope here. So what's the spectral signature of this? So by comparing life to non-life, we can get at the question, are there biosignatures there and are they indicative of life? Our planet, for 80% of its history, has been dominated by very simple microbial life, photosynthetic life. These guys can colonize and inhabit just about any environmental niche out there. So I go to all these environmental extremes and measure, how they live there, how they grow there, what they look like, what their spectral signature is, so that we can build up a database of all these different habitats and all these different extremes that would help us interpret any spectral signature that we might get back from an exoplanet.